In this video, I'm going to be showing off mathematical operations I made for a computer I'm going to build in Scrap Mechanic. This is part 1 of a series where the next episode is going to be memory, and the episode after that is probably going to be the actual control circuits and maybe some different I/O peripherals. So let's get right into it. So, the first operation is addition. This is a simple carry look-ahead adder, which is divided into 4-bit segments, so it's easier to manage, easier to build. However, that does limit quite the speed by quite a bit. Each of these stages takes approximately 4 ticks, so all in all it takes about 16 ticks to complete, and it works quite well. So 5 plus 5 is indeed 10. Now, the problem is, what about subtraction? Because that is technically important for this uses case. So, the way to do that is using 2's complement. Basically, the highest value in the binary number, so the most significant bit, which is this, is actually negative. So in this case, it would be negative 32,768. So negative 1 would be this, right? So so 0 minus 1 is of course 1, and then 1 minus 1, 0, 2 minus 1 is 1, and so on. Next operation is this massive multiplication machine that works in approximately 1.5 seconds, which is kind of fast. It uses multiple parallel levels that are placed on this giant bit shift matrix that I made. So let's go 5 times 5. All these layers are basically full adders that with a carry, and they go up, and in the end I get the result right here, which is 1 plus 8, that's 9, plus 16, that is indeed 25. There's not much to explain here, except the fact that it is technically just a lot of additions. It works the same as long multiplication. However, all that changes really is the fact that it's all in the same in all in layers, so it actually does the multiplication faster than if it was just 16 additions. So yeah, that's it. Now, this is a monster. This is division. It took me a while to figure out. However, the simple way is all of this is just for controlling the repetition. All this is the actual logic. From what I know, it's non-restoring division. So, overall, it compares the two input values, or the remainder, which is stored in blue, and the divisor, which is green. Then it is compared. If remainder is equal or greater than the divisor, it is subtracted with this massive subtractor, which uses the same carry look ahead adder that I showed just earlier. And I also have this, and then the bit here is set. So yeah. Now, as an example, let's set our 25, which was 1 plus 8, that is 9, plus 16. Let's divide it by 5. And when I activate it, it's going to take approximately 30 seconds because there's a lot of stuff happening. And since I have to account for approximately 32 ticks, at least every single cycle. So when I start it, it initializes all these registers, so it pushes all the data through, and then every single approximately 1.75 seconds it cycles again, pushing all these numbers forward by 1, and comparing, subtracting if necessary, otherwise just sending it through and continuing on. Now, just here it's subtracted, leaving us with 1, it's subtracted again, leaving us with 0, and then finally over here is our result, 101, which is of course 5. Now, the last thing is this simple bit shifter, which, well, does what the name suggests. 5 is, of course, I must have not connected something. Where? Why? Why are you not? Let's do that again, cause okay. And this is a bit shifter. It shifts the bits by the amount of spaces specified right here. So if I have 5, I shift it by 1 bit, then that means I multiply it by 2, since each space shifted is in fact a multiplication by 2. So that is 10. Then let's say I want to shift it by 4 spaces. That would be 4. That means that I multiply it by 1, 2, 3, and 4 times 2. So that is by 2, by 4, by 8, by 16, and 5 times 16 is in fact 80, which is 16 plus 64, which is what we got. Now, how would I do the bit shifting in the opposite direction? Well, that's simple. I just switch the most significant bit from this position to this position and do the same on this side. Because then I just basically have the mirror operation of what I have here. Now there are a couple more operations that I was supposed to build, however they're really actually simple. So one of them is AND, which is simply this. It checks if both inputs are active and then sends an output. And the only real reason I would build it is because I would have it 16 long like everything else, because it's going to be 16-bit in the end. Now, the another operation would be an OR, which does what the name suggests. It takes if it's activated if either of the inputs is active. So, OR. Then we would need an exclusive OR, which is only activated if one and not both are active. So one is active, that's cool. Both are active, that is, then it turns itself off. And another one would be negation. Sadly, Scrap Mechanic does not have a default NOT gate. However, it's really easy to use just one. Since I'm only really negating one value, that means that it's as simple as that. And those are all the operations that the CPU that mathematical operations that the CPU is going to have available. Now, in the next episode of this series, I'm going to be working some more on memory, so we can actually store the data we generate using these operations. And anyway, I'll see you guys next week.